Hello there and welcome to another short video on solving a LeetCode problem with APL. My name is Rodrigo and today we will be tackling problem 566, which is called Reshape the Matrix. Now, this series of videos are supposed to represent my first attempts at solving a problem. So usually I record myself reading the problem for the first time and then trying to solve it in APL. That's why sometimes I don't come up with the shortest solutions or the most idiomatic ones, because I just want you to see how it looks like to think in APL. And I just recorded this video and then I noticed that I actually missed a part of the specification of the problem, so I'm re-recording this. And why is that? Well, the problem statement says essentially that given a matrix like this one here on the left and some new dimensions, I should reshape the matrix into its new shape. And in APL, that is really simple because it's just one single primitive that does that. And that's the Greek letter rho. But then, in the end, and I missed this sentence, it says that if I am given a new shape that is either bigger or smaller than the current shape of the matrix, so if it's going to hold more items or less items than the current matrix has, then I should output the original matrix. I shouldn't do anything. And this was a problem because APL's rho primitive, so the reshape function in APL, doesn't do that. So to be pedantic about it, I didn't solve the problem because I just missed this part of the specification. So I've been talking about this Greek letter rho, the reshape function, and to show you what it does, if I have this vector over here, that's just a vector. Think of it like a list of numbers. So it's a vector, it's a one-dimensional thing. And now what I want to do is I want to turn it into a 2x2 matrix, like I have in here. So in order to do that, what I say is, well, let's do a 2x2 reshape of that. And now I have the matrix over here. So most of the solution is just this single primitive. And then I can do, for example, let's make it a 1-4 matrix. And so I can just take the 1-4 reshape here on the left. And this is the bulk of the work. But now I need to do something else. So there's no... Yeah, there's a test case like that. So there's this matrix over here, the same matrix, and then the new shape is 2-4. Now a matrix that has 2 rows and 4 columns has 8 elements, but this original matrix only has 4, and so what they say is, well, there's not enough data to fill in the new matrix, so just return the original one. But in APL, what would happen is, so if I have this input, which is the 2x2 matrix, and if I do 2x4 reshape of the input, what APL does is it recycles the data. Okay, so it starts to fill in row-wise order, so it starts to fill the first row, and then when it's done filling the first row, it starts recycling the data for the second row. Maybe if I do it like this, it will show you how it's recycling the data. So 1, 2, 3, 4, that's the original data, and then it ran out of data, and so it starts reusing it again. But we don't want this, we want to return the original matrix. So what we can actually do is, to define our solution, we can say, well, let's make it a, I think I need to enable multi-line input, so sorry for that. Let me configure my session extended multi-line input, yes. Okay, so I want to be able to type multiple lines in the session. Okay, so now what I'm going to do is, if my new shape comes on the left and the original matrix comes on the right, what I can see is multiply the two numbers that come from the left, and that's just alpha, and check if it's different from the number of elements, so the number of elements in the shape of the matrix, because if it's different, I want to return the matrix unchanged. Notice here that I'm using, it looks like reshape, but I'm only giving it a right argument. So this is asking for the shape, and then I'm multiplying all of those numbers in the shape. And otherwise, so if the number of elements in the matrix matches the number of elements in the new shape, then I just do a reshape of that. And so, for example, 2, 4 on the input leaves the input unchanged. And just to show you what this line is doing, I have, so this goes from, it reads from, or it executes from right to left. So I have the shape of the input, and that's the 2x2. It gives me 2 rows and 2 columns. And then the times reduction is the same as a product of all the numbers. So it says, well, the original matrix has 4 numbers. And then with the parentheses here, I'm doing a times reduction on the input, which was 2, 4. And so the 8 is different from the 4. So 8 is different from 4. So this evaluates to true, to a 1 in APL. And as it evaluates to 1, it just executes this thing. And by executes, I mean it just returns, it's returning this single thing unchanged. And otherwise, so if, for example, if the input were 1, 4, it does the reshape. And why is that? Because this line over here, so this line over here is going to be executed with the 1, 4 on the left and with the input on the right, and it evaluates to false. And so this thing isn't returned, it goes on to the next expression. And so if you want to look this up later, this is called a guard in APL. So it's a guard. Okay, so now we have our complete solution. So as we can see, there's the main reshaping operation is just done by this, the reshape primitive, and then we just do the check with a couple of times reductions and a, what do you call it? A not equals. And actually I just thought of something that's cool. So if you're learning some APL and you want to get, better and if you want to learn new things, we can actually rewrite this as, can we? Well, we can. It's not the cleanest thing ever. I thought it would look cooler in my head, but we can see that, so we have this pattern. There's the alpha and the omega, and these things that are being given as arguments to not equals, both of them are having a times reduction applied to them. So it's essentially we want to do this not equals comparison after pre-processing both arguments by the times reduction. And this idea of pre-processing both arguments can be done with a primitive called over, which is this big O with 2 dots on top. And so this means let's see if they are not equal after pre-processing both arguments with a times reduction. Now the times reduction needs to be parenthesized here, and then we can have the alpha and the shape of omega and just return omega there. So this looks interesting, and it's another solution. So 1, 4 sol input, and then 2, 4 it does nothing. Okay, so if you are learning APL and you want to learn new operators and these new interesting things, I can recommend that you take a look at this operator right here, the over operator. That's over there. Yeah. Okay, so that's it. I hope you learned something new. If you have alternative solutions, feel free to leave them in the comments below, and otherwise, I'll see you in the next video. Bye.